Yeah, guys. What we discussed yesterday? Yesterday we discussed about the replication controller, right, guys? So replication controller. We discussed about the replication controller. Yeah. What is a replication controller? It is one of the key feature in the Kubernetes cluster. It is responsible to manage pod lifecycle. It will make sure given number of pod replicas are running at any time point of time. If any pod got crashed, deleted, dead, then a replication controller will replace it. Replication control is providing facility to create multiple pods, and it will make sure pods always exist to run our application. Using replication controller, we can achieve high availability. A replication controller and pods are associated with the labels and selectors. This is the most important, guys. The labels and selectors. So replication control, it is a K8s component which is used to create the pod. What is this, guys? It is a K8s component which is used to create the pods. It will make sure always given number of pods are running for our application. So it will take care of the pod life cycle. When pod is crashed, damaged, deleted, then RC replication controller will create a new pod. So we can scale up and scale down the pods count using the replication controller, using the replication controller. So that kubectl delete all kubectl apply rc.yaml yesterday we created, right? So something like get svc rc is nothing but a replication controller. Kubectl scale rc, so something like the pod name and replicas 5, it will it will increase the replicas, it will decrease the replicas, scale up and scale down. Kubectl delete, so that replication, right? This is the replication. So replication controller, this is the file we already showed, right, at yesterday. Yeah. So what is replica set? What is the difference between replication controller and replica set? So replica set is replacement for the replication controller. So what is that, guys? A replica set is a replacement. Replica set is replacement for a replication controller. It is a next gen component in Kubernetes. Replica set is also used to manage pod lifecycle. Replica set is used to manage pod lifecycle. Replica set also maintain the given number of pods always. So we can scale up and scale down our pods using the replica set also. The only difference between a replication controller and replica set, just a selector is a selector. Guys, there is no difference between replication controller and a replica set. Replica set is a replacement for the replication controller. It is a next gen component in Kubernetes. So replica set is also used to manage pod lifecycle. Replica set also will maintain given number of pods always. So we can scale up and we can scale down our pods using the replica set also. The only difference between replication control and replica set is a selector. So the difference between replication controller and replica set is the only difference between replication controller and replica set is a selector. So selectors. So the replication controller supports equality based selectors, and the a replica set supports set based selectors. What is that, guys? So a replication controller supports equality based selector. Replication controller supports equality based selectors. Replica set supports set based selectors. So what is that selector? A selector is nothing but a equality based selector is nothing but a just a selector. So we can add the selector, but the replica set supports the set based selectors. Set based selectors means multiple selectors we can add. So multiple, if you want to add multiple here, equality based selector, only one selector will add in the replication controller. But replica set, we can add the we can support the set based selector. Set based selector means we can add the multiple selectors. So if you want to add the multiple selectors, so we need to use the match labels. So we need to use the match labels. Match labels and app is Java web app, version is v1, type is a backend. For example, these are the three types of selectors. These are the three types of selectors. The set based selectors and equality selector. Equality is only one selector. Set based selector is nothing but we can select multiple selectors. So app is one selector, version is one selector, type is one selector. So now you got it, guys. Now you got it. The replication controller and the replica set. So replication controller only supports for the selector. A replica set is supports for the set based selector. This is equality selector. This is the set based selector. Examples of the equality set, equality and set based selectors. For example, equality selector app, the selector name, label name. Set based selectors are selectors, match expressions, key, operator, values. This is the equality of a selector. So replication controller versus replica set in Kubernetes. So Kubernetes replica sets, it can be considered as a replacement or a replication controller. The replica set and the replication controller's key difference is that the replication controller only supports the equality based selectors, whereas the replica set supports the set based selectors. Replica set supports the set based selectors. The replica set and the replication controllers, the key difference is the replication controller only supports the equality based uh, selectors, whereas the replica set supports the set based selectors. Set based selectors. Okay, guys. So we'll write one example. Match label. So what is this, guys? So this is a strategy type recreate selector match label. Yes, guys. So match label. So for example, so this is the a match label selector. Yesterday we discussed about just a replication controller. So replication controller. So today we will discuss about the replica set. Replica set is only difference between to select the set based selectors. So we can provide the match labels, app version we can select it. Guys, understood? You can understood? So yeah. So the deployment, for example, this is the strategy, right? So we will, so cat replica set, guys. So cat replica set, in the replica set we can provide the version v1 and deployment kind equal to so that replica set. So we can use the replica set, or else we have a file, guys. Let me take that file, replica set file. Yeah. So for example, this is the replica set.yml. API version equal to apps v1. Apps v1. The difference between replication controller and replica set. So we are providing the match labels, right? We need to provide here that apps hyphen v1 kind equal to, what is the kind, guys? So kind is a replica set. What is the kind, guys? So kind is a replica set. Replica set. So kind is a replica set. The metadata. So the name of the metadata nginx web app. So web app rc web app rc is nothing but a replica set rs. So spec equal to replicas equal to 3 strategy. So as of now we are removing the strategy. Strategy is nothing but a deployment. Yeah, selectors, match labels. So only difference between, so we need to provide the match labels. We need to provide the match labels for the replica set. So nginx web app template metadata name. So nginx web app pod labels nginx web app. The spec containers nginx web app image nginx port container. So we will provide the target port. So target port in the port is 80 and the node port service manifest file. API version v1 kind service metadata name svc the spec type equal to node port selector app ports target port and the node port also. We need to provide the node port colon. What is the node port, guys? 30245. So we are providing the node port. Then so we can close the file. So we can close the file. So this is nothing but a label and a replica set. So the API version apps v1 kind equal to replica set. What is the kind? A replication controller pod kind equal to pod kind equal to svc service kind equal to service kind equal to pod kind equal to replica set kind equal to replication controller. So replication controller. So now we are using replica set. What is the difference between replication controller and replica set? So we need to provide the match labels. Match labels means the set based selectors. We need to provide the set based selectors in the replicas, right? So it is a high availability at any given point of time. So only 3 parts will running. So this is nothing but a replica set manifest file. Let's copy this. Putty. Gosh, guys, 1 second. Select auth credentials. Remote EKS. Open. Change settings. Appearance. Change. The bold 18. Okay. Okay. Ubuntu. Yeah, guys. So Ubuntu, right? Yeah. ls. So we will provide the replication controller. Replica set dot aml. What is that, guys? Replica set dot aml. Yeah. Again copy, paste it. Replica set. Three events. The file starts from 3 events, and this is hash is nothing but a comment, guys. So this is replica set manifest file. So this is the replica set manifest file. So okay guys, API version, kind, metadata, spec, replicas 3, selector match labels, app, template, labels, spec, containers, engine export container, engine app. Okay, 30245. Yeah, let's close it. So now, so what you can do, guys? What you can do? You guys can delete the everything. kubectl delete all all. So kubectl delete all all. It will delete everything. kubectl get parts. kubectl get parts. kubectl get svc. Get svc only Kubernetes. Put rc replication controller. Get rs. No namespace found in the default namespace. Okay, rs nothing is there. So nothing is there. We already created the replica set. So replica set kubectl apply -f replica set.aml. Replica set dot apps nginx web servers created. Service nginx svc is created. nginx svc is created. Let's check, guys. kubectl get parts -o wide. You see, guys. So how many parts? Three parts are running. How many parts? Three parts are running. Three parts are running. kubectl get svc. Get svc. Yeah. So node port is created. Node port service is created. kubectl get rs replica set. You see, guys. So the replica set, so what is the replica set name? nginx web servers rs replica set desired 3 current 3 ready 3. So desired 3 current 3 ready 3. I want to scale up and scale down. How you can do it? kubectl scale kubectl scale rc. So rc, what is the uh, rs right? So rs scale down rs web and nginx web app rs hyphen replicas 5. So how many we have? We are trying to scale up the replicas. We want to scale up the replicas. Yeah, replicas at nginx is scaled. Now let's check the parts. So how many parts are running? 5 parts are running. How many parts are? 2 parts are so running just now, right? So we can scale up and we can scale down. How you can scale down? So we can use replicas scale down. You see replica set acts scaled. So so before it is scale up to 5. Now scale down to 3. Now scale down to 3. Guys, understood? The replication controller and replica set. Replica set. kubectl. Kubectl get parts -o wide. -o wide. 3 parts are running, right? I want to delete a one part. So kubectl delete pod name. So what is the pod, guys? For example, this is the pod. So I'm deleting this pod. Yeah. You see, guys, just 3 seconds ago it is created. So what is the replicas, guys? The replica is the replica is the replicas is 3. So the replicas is 3. So that is the reason the high availability, the available every time if it is a crashed, So if it is crashed or something like it is a Kubernetes component which is used to create the pods. It will make sure always given number of pods are running for our application. It will take care of the pod life cycle. When the pod is crashed or damaged, deleted, then RC will create the replica controller, or replica set will create the new pod. Replica set will create the new pod. Guys, understood? So we can scale up and scale down. So replica set also will maintain the given number of pods always. Always. So but the difference is from the replication control and replica set. So replica set has having the set based selectors, and replication control having the only equality based selectors. So daemon set, guys. A daemon set ensures that all nodes run a copy of the pod. As nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. Deleting a daemon set will clean up the pod is created. So pod is created. A daemon set ensures that all nodes run a copy of the pod. A daemon set ensures that all nodes run a copy of the pod. As nodes are added to the cluster, pods are added to them. Nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. So deleting a daemon set will clean up the pods it created. Some typical use cases of the daemon sets are so running a cluster storage daemon on every node, running the logs collection daemon on every node, running the nodes monitoring daemon on every node. So note replicas not applicable for the daemon set. So because of so it is the copy of the pods will run on the another node, another node. So manually pod created, not recommended. Yeah. So pod creation replication controller. So manually pod created, not recommended. Pod creation using replication controller, recommended. Pod creation using replica set, recommended. Pod creation using the daemon set. In the above concept, auto scaling feature not available manually. We need to scale our pods, right? So we need to scale our pods. We just scaled our pods, right? So this is scale up and scale down. But yeah. So the above concept auto scaling feature not available manually. We need to scale up and scale down the pods. So there is no option to roll back our pods creation. There is a no rollback option to pod creation. To overcome these problems, we have a deployment. So what is that, guys? So we have a deployment. Deployment. So deployment is one of the Kubernetes resource as a component. Deployment is the most recommended approach to deploy our application in the Kubernetes cluster. What is that, guys? So they are not using the replication controller, replica set, everything. They are using the deployment. Because of deployment enables the auto scaling and rollout and rollback, zero downtime deployment. Guys, understood? So deployment is one of the Kubernetes resource and component. Deployment is the most recommended approach to deploy our application in the Kubernetes cluster. Using deployment, we can scale up and scale down our pods. Using deployment, we can scale up and scale down our pods. Deployment supports the rollout and rollback. Rollout is nothing but one feature is deployed under the Kubernetes. So I want to roll back immediately. So how you can roll back? By using the rollback option. We can achieve this in the deployment. So we can achieve this in the deployment component. So to deploy latest code, we have delete the RC and RS. Then pods will be deleted and application will be down. To deploy latest code, we have to delete RC and RS. So RC and RS, then the pods will be deleted and the application will be down. Right, guys? Application will be down. So we can deploy latest code with zero downtime using the deployment. So zero downtime. So what is the downtime, guys? Zero downtime deployments. By using deployments, we have a zero downtime deployments, rollout and rollback, and auto scaling. So zero downtime deployments is nothing but a deployment strategies, guys. So deployments strategies. Deployment strategies are, so we have the below deployment strategies are recreate and rolling update. So what is the deployment strategies? Deployment strategies are the recreate and rolling updaters. So in our organization, we are using the rolling update. So rolling update is nothing but recreate and rolling update. The rolling update is nothing but a recreate is nothing but a, so at a time the pods are deleted at a time. So there might so the application will down up that time they are not using we will not use the application because of the site cannot be reached. So once it is down everything, then it is that is come up, that is nothing but a recreate. So what is a rolling update? Rolling update is nothing but a one pod will crash and new pod will come. So another pod will crash, another pod will come. The another pod will crash, another pod will come. This is nothing but a rolling update. In the rolling update, the application the site will not goes down. So recreate means it will delete all the existing parts and it will create a new parts. It will delete all the existing parts at a time and it will delete. Downtime will be there. So rolling update strategy means it will delete the parts. It will delete the parts. Create a new part. Creates a new part one by one. So one by one. If you don't specify the deployment strategy, then by default it will consider as a rolling update. What is that, guys? By default it considered as a rolling update. Rolling update. So recreate and the rolling update. So something like a strategy, a recreate. So recreate is nothing but this is the node, this is the container, this is the part one, part two. So the deployment.yaml strategy is a recreate. So strategy is recreate. If we use the strategy recreate, it will delete the parts and recreate the parts. So whatever the previous parts available, those are delete and will recreate the parts based on the replicas. Recreate means existing parts will be deleted and new parts will be created. Application will don't have a downtime or will have a downtime in the recreate strategy, guys. Will have a downtime or not a downtime in the recreate. So application will don't have a downtime or will have a downtime, guys. So it will delete everything and create a new ones. Create a new ones. Guys, tell me, the application will don't have a downtime or will have a downtime? Yeah, will have a downtime because of every pod will delete and recreate the pods. So there might be a downtime. So recreate strategy. So recreate something like recreate and the strategies are recreate and rolling update. So recreate all existing pods are killed before new ones are created. So when a strategy. The rolling update, all the existing pods are killed before new ones created. This is recreate. Rolling updates, it will be delete one by one pod and create one by one. One by one. Guys understood? So the deployment I will show you, guys. So I will show you. So we'll create a new deployment manifest file, pod deployment manifest file. So what this is, guys? This is a pod deployment a manifest file. So in the pod deployment manifest file, replica set deployment. So the deployment manifest file, the deployment manifest file. So what is that, guys? So API version apps v1 kind equal to deployment. So in the real time, so which approach they are using, guys? Which component they are using to deploy the applications? They are using the deployment component. They are not using the replication controller. They are not using the replica set. They are not using the daemon set. They are not using the pod because of there is so deployment have a strategy to recreate and rolling update, and the adapt. So if you use the deployment zero downtime and the auto scaling and the auto scaling, zero downtime, a rollout and rollback. So by using deployment, we can roll back the changes. So we can roll back the changes. So metadata, name, the Nginx web deployment, spec, replicas. The deployments also we can provide the replicas, auto scaling here, replicas, strategy. So in the RS, we are not adding the RS replica asset or replication center, we are not adding the strategy, but in the deployment component, we use the a strategy called as a recreate or recreate or recreate or rolling update. So recreate or a rolling update. For example, recreate guide. So recreate a selector. So we can use the replica set here, match labels. So match label equal to Nginx and the template metadata Nginx web app label equal to Nginx web app. So the selector and the label, the selector and the label will be matching, will be matching spec container name Nginx web app image Nginx ports container port. So node port service manifest the service manifest file you already knows, right? Here we will add the node port, node port 30255. For example, we are using the node port 30255 30255 and close the file. Close the file. Starting file, we need to add the yes. So this is the pod deployment manifest file. Guys, understood? So what is that? Only a strategy. Strategy type equal to recreate or rolling update. So what is that, guys? Recreate all rolling update. Recreate or a rolling update. Guys, understood? The only difference is the file name is deployment. In the API version, right? The apps.v1. Apps.v1. We will provide the apps.v1. Namespace. So replica set, replication controller, deployment. So zero downtime deployment, rollout and rollback, auto scaling. Right, guys? So recreate and rolling update. So recreate and rolling update. Recreate and rolling update. So this is the file, right, guys? So we can copy this file, deployment file, copy, and I think it will duplicate session, Ubuntu, Ubuntu. Yes, I'm deleting this. Yeah. So kubectl get parts, get parts. Yeah, it will be running, right? This is a RS. RS is nothing but a replica set. I want to delete everything. Kubectl delete, kubectl delete all all. Yeah. So we will create a deployment dot YAML. So we'll create the deployment dot YAML. Yeah. So this is the app version app v1. The kind is equal to deployment. The replicas 3, strategy recreate, selector match labels app, the template, a label equal to nginx wrap, container, port. So this is the service file. Service file you already knows, right, guys? WQ. kubectl, guys, kubectl apply -f deployment.aml. So deployment apps, nginx deployment created. So what is that, guys? kubectl get parts. Yeah. So it's created. Deployment parts are created. kubectl get svc. kubectl get rs. Yeah. So rs also created. Replica set and deployment. Yeah. So deployment also created 3 by 3 up to date and 3 available 39 seconds ago. So what is that, guys? So the deployment file is created 3 by 3 ready up to date 3 and available 3 and available 3, guys. So I want to delete the kubectl delete pod is the pod I'm trying to delete it. Yeah, let's try to shit. You say, guys, 5 seconds ago, 5 seconds ago it created. 5 seconds ago it created. Guys, understood? So this is nothing but a recreate. So recreate under rolling update. So recreate under rolling update. Guys, understood? Guys, Vinay, Funny, Lavanya, understood?
Understood. Sorry.
So deployment file. So what is that? That is a deployment file. Deployment. So it is a deployment is one of the K8s resources component. Deployment is the most recommended approach to deploy our application in Kubernetes cluster. Using deployment, we can scale up and scale down the pods. Deployment supports rollout and rollback. So to deploy the latest code, we have to delete RCRS, then the pods will deleted and application will be down. Right. So we don't need a zero downtime. So for example, if you delete the kubectl, delete rs rs name. So give svc. This is rs, right? Replica set is deleted. Replica set is deleted. Even replica set is deleted. It will be running, guys. It will be running. So for example, I want to delete the deployment. I want to delete the deployment file. What is the deployment, guys? The deployment is deleted. Yeah. So even so rs is deleted. No. So that if the deployment deleted, then so it will delete the everything. It will delete everything. kubectl delete all all. Yeah, guys. Now let's check kubectl get pods. No pods. kubectl get svc. kubectl get rs deployment. Is understood? So everything will be deleted. This is the a strategy of the deployment. The strategy of the deployment is two types. One is the deployment strategy is two types. One is recreate and rolling update. So recreate and rolling update. Guys, understood? So the pod is a rolling update means recreate means it will delete everything at a time and it will update, and it will for rolling update we can use one by one. So we can use a one by one. Guys, understood? Yeah, this is the deployment strategies. So tomorrow we will discuss about the. So tomorrow we'll discuss about the blue and green deployment model, guys. What is that? Blue and green and deployment model we will show you tomorrow. What is blue and green deployment? Advantage with the blue and green. Advantage with the blue green model. Practical. So auto scaling. It is the process of increasing, decreasing infrastructure based on the demand. Auto scaling can be done in two ways: horizontal scaling and vertical scaling. Horizontal scaling and so vertical scaling. Horizontal scaling means increasing the number of instances systems. Vertical scaling means increasing the capacity of the system. Increasing the capacity of the system. HPA, horizontal pods auto scaling, horizontal pod auto scaling, and vertical pod auto scaling. So we don't use this in the Kubernetes. We use only HPA, horizontal pod auto scaling. Horizontal pod auto scaler, which will scale up and scale down the number of pods, replica of the deployment, replica set or replication controller dynamically based on the observed metrics, CPU memory utilization. HPA will interact with the metric server to identify the CPU memory utilization of the pod. So note, for production, we will use the horizontal scaling. So horizontal scaling versus a vertical scaling. So while horizontal scaling refers to adding additional nodes, a vertical scale describes adding more power to your current machine. For example, this is your current machine. It will increases the CPU RAM. But horizontal scaling is nothing but a HPA is nothing but a horizontal pod scaling is nothing but a it will increases the instances, increases the pods. Okay, guys. So metric servers top get kubectl top nodes to get pods metrics kubectl top pods. So by default, metric service is not available. Metric service is an application that collect metric from the objects such as pods, nodes according to the state of CPU, RAM and keeps them in time. RAM and keeps them in time. So metric server can be installed in our system as an add-on. You can take and install directly from the repository. So we'll show you guys. So we'll show you tomorrow. So something like EKS cluster, you know, right? Ingress. Ingress is used to map external URLs to the cluster. Kubernetes cluster service. Pods are accessible within the cluster. To expose the pod outside the cluster, we can use the service concept. So we have a three types of service: cluster port, node port, and LBR, right? LBR. Ingress example, something like a domain, ingress, and services, and the pod. So ingress is used to map external URLs to the Kubernetes cluster services. Pods are accessible within the cluster. To expose the pods outside of the cluster, we can use the service concept. So we have a three types of services in Kubernetes: cluster port, node port, and LBR. Right, guys? Yeah. So we'll discuss tomorrow blue and green model, and then we will discuss the ingress and the auto scaling. Okay, guys? Now you understood, right? The deployment. So finally, the real time they are using the deployment file. Yeah, guys. So this is the deployment file, and we can provide the nginx label, replicas, and selectors match label. Match label is nothing but a replica set we are using here. So right. So this is the deployment file. So this is the a deployment file, guys. Yeah, so this is also a deployment file. So run the nginx container using the AML. So this is the nginx, guys. Nginx. So this is a pass environment variables in the Kubernetes deployment AML. Use multiple replicas. We can use the replicas 10. So Kubernetes deployment YAML with the resource limits. Yeah. So this resource limits, guys, will show you the resource limits also. A spec, right? In the spec container port, resources, limits, memory, and request. So maximum memory allowed, maximum CPU allowed. So initial memory request and initial CPU. So initial is a request is nothing but a initial, and the limits is nothing but a maximum. So what is the resources, guys? The resources, the limits and requests. So resources, this section is used to define the resource request and the limits for the container. Limits, limits specifies the maximum amount of the CPU and the memory that container is allowed to use. In this example, the container is limited maximum to 56 of the memory and 200 milli CPUs. So request specifies the initial amount of the CPU memory and that container request when the starts. It's an example. Container request 12 MB memory and 100 milli CPUs. 100 milli CPUs. Guys, understood? So this is nothing but a resources limits and request. Resources limits and request. And this is the health checks. Health check, how you can check the Kubernetes deployment YAML with the health checks. So we can add some health checks to our deployment YAML to include. So health check is nothing but a liveness probe and readiness probe settings. What is that, guys? So the liveness probes and readiness probes. So liveness probe and readiness probe. So liveness probe, so the liveness probe checks whether the container is still alive, or it is uses then an HTTP GET request to path to the port of the container. If the probe fails, it will start the container. Readiness probe. So liveness probe and readiness probe. The readiness probe checks whether the container is ready to serve the traffic. It also uses an HTTP GET request and path to the ETH container. The probe fails, the container marked as a not ready. So container will not send the traffic. So it will restart the container liveness, it readiness, it will won't send the traffic. So something like so liveness probe and readiness probe. So liveness probe HTTP get path 80 and initial deployment seconds equal to 51, period equal to 10 seconds. So readiness, so the initial 5, period equal to 5. The path to check for the liveness probe, the port to check on. So wait this many seconds before starting the probe, check the probe every 10 seconds. The path to check the readiness probe, port check on. So wait the many seconds before starting the probe, check probe every 5 seconds. Guys, understood? So this is nothing but a liveness and probe readiness probe. Persistent volumes. Yeah, guys, I will show you the persistent volumes. Persistent volumes. So we will use it, guys. Persistence volumes. So we will use it. So affinity settings also. Pod affinity. So these are the few examples, guys. They are the a few examples. Got it? Resource and limits. This is the resource and limits. This is the healthy checks and persistent volumes and affinity settings. So no need of, guys, daemon set, stateful set. Guys, understood? So these are nothing but a deployment file, guys. In the real time, they are using the deployment manifest file to deploy our applications. Guys, got it? Guys, got it?
Yes.
Yeah. So we'll continue from tomorrow.